Well, CO2 batteries in general are just an emerging area right now. So the conventional CO2 battery consists of a lithium or sodium anode, CO2 cathode, some kind of carbon material in which the reaction occurs, and a non-aqueous electrolyte, and no amine. And in that case, one can discharge and recharge the battery to a very limited extent. The charging reaction in particular is quite limited by high voltage required to decompose the carbonate material and go back to CO2. So this is a separate but parallel and somewhat overlapping area of research. Our approach has focused much more on the technology of incorporating the capture and discharge steps. And we're now looking at how we can bring that back towards a system that can cycle back and forth. So we've learned a lot about the discharge reaction. We can facilitate the process by using the amine. And future work needs to look at how we can reverse the process so that we can have a viable system that can cycle with low round-trip efficiencies and long lifetime. So we've recently completed a demonstration of concept that one can chemically design a medium that can capture the CO2 and activate it for further electrochemistry. I think that's a big step. And now we're looking at how to build the rest of the system around this process. So I think when we are thinking about having a battery that we could hold in our hands, it might be 3 to 5 years away or so, at best. And thinking about CO2 conversion reactions, I think probably a similar time scale. I think it can be done. It's a matter of how many people can we get working on these systems so that we can crack some of the more fundamental issues. So we have seen a lot of interest in the technology from power plants and from industries that create a lot of CO2 emissions. So both within the US and outside of the US, there's increasing interest. Companies want to clean up their emissions. They want to have sustainable operations. And to the extent that governments are incentivizing recycling or capture management of CO2, I think there will just be continued interest in investing in these types of technologies. And what we need are, in my opinion, two speeds. Investment in really the fundamental research, so the molecular processes that underlie these transformations. That's what we've been focusing on so far. But also, how do you take that from a sort of chemistry or electrochemistry material stage to a device prototyping stage? I'm in the Department of Mechanical Engineering, so we're interested in bridging these scales. We've so far started with more fundamental proof of concept. Can these amine CO2 reactions actually be harnessed to open up new reaction pathways? We found that they can be. And so now we're interested in doing the R&D to take it from something that works in the laboratory to something that can be scaled and hopefully operated at the scale one day of power plant capture and emissions.